Multiplying special cases. There's two different kinds of binomial multiplication problems that are kind of a special case. Believe it or not, there's just an extra little thing that you have to think about. Really, they're the same thing. This first one, x minus 7 to the second power. Here's the problem. Everybody wants to take and just square the x and square the 7, and you cannot do that. You will not get the right answer now. You will not get the right answer ever. X minus 7 to the second power means you have x minus 7 squared. So x minus 7 times x minus 7. Now, when we go to start to work for that, we do the same thing we did previously. Distribute the x times both of these pieces, distribute the 7, negative 7 times both of these pieces. The FOIL method, first, outer, inner, last. So x times x gives us an x to the second, and x times negative 7 gives us a negative 7x. A negative 7 times x gives us a negative 7x, and then a negative 7 times a negative 7 gives us a positive 49. These like terms in the middle do not cancel out, so therefore we have more than just x squared plus 49. We have x squared, a middle term of negative 14x, and a 49. Okay, if you just square the x and square the 7, you will not get the right answer. All right, so that's the one kind. The other kind is called the difference of two squares. So you have an x plus something and an x minus something, the same something. Okay, so x plus 9 and x minus 9. Down here we have a 6 plus m squared and 6 minus m squared, or 3c minus 4 and 3c plus 4. Okay, these are called, well, they call it the product of a sum and a difference, so I call it the difference of two squares. So, same thing, distribute. X times x, x times negative 9, 9 times x, and positive 9 and a negative 9. This time, negative 9x and positive 9x add up to 0x, and we end up with just two terms. X squared minus 81. All right, so every time that happens, every time we have a plus 9 and a minus 9, we have the opposites here. Pretty much they're going to add up to the 0, and we're not going to have that middle term. Keep that in mind when we go to do the reverse here, when we start factoring here in a lesson or two.